Welcome to a demonstration of using ADS design guides and utilities to transform passive networks. We will begin with the Filter Design Guide, a complete solution for passive filter design. It is fully integrated with ADS and features several automated assistants, including an interactive filter assistant for graphically aided specification of the filter you want to design. Transforms are also available in the impedance matching utility. To perform a transform, the Transformation Assistant may be launched after the network has been synthesized. Options include transforming to ideal transmission lines, Kuroda transforms for transmission lines, and lump components or transmission lines to microstrip structures. The component types are selected and the desired structure is chosen from the options given. As each component or group is transformed, the schematic updates automatically. To design the filter that will then transform, let's open the Filter Control window, select the filter palette, and place a doubly terminated low-pass filter onto our schematic. Then associate that smart component with the Filter Design Guide. Opening the Filter Assistant tab, we'll select the Chevy-Chev response and accept the default values. When the filter is designed, only one network will be created. We can push into that design to see the network. Now we'll simulate the network and view the response. We can see that we've achieved the desired Chevy-Chev low-pass response. Next, we'll launch the Transformation Assistant to perform the transform. The Transformation Assistant provides several options. We can convert from lump components to transmission lines, from series to parallel and vice versa transmission lines, and lump components or transmission lines to microstrip. For this part of the demonstration, we'll convert to transmission lines. There are two types of components in our design: series inductor, shunt capacitor. Only those components are shown, all the others are grayed out. Selecting the inductor, we can add all instances of the inductor, in this case there's only one, and then select the component that will give us the optimum frequency response as marked in blue. Select Transform to transform the inductor. Now we'll return and select our capacitors and also transform them in the same manner. Now we can push in and view the transformed network. We'll rerun the simulation to see how the response has changed. We can now see that our response still has a Chevy-Chev characteristic with a cutoff at 1 GHz as it did previously. Now that we've transformed our filter to ideal transmission lines, let's now transform it to microstrip. Starting with the inductor, we'll transform to a transmission line. And we'll change the characteristic impedance to 70 ohms. For the capacitor, let's select the biradial stub for both instances and transform them. Pushing into the smart component, we see the transformed network. Let's run a simulation to verify the response. The transformed filter response still has a Chevy-Chev characteristic and a cutoff frequency of approximately 1 GHz, as expected. Now we can auto-generate a layout. Now we have designed our filter and successfully transformed it to a layout prototype. The Design Guide utilities and transforms integrate tightly within ADS convenient and versatile synthesis of filters and matching networks, and also support transforms to both ideal transmission lines and microstrip elements and layout. Thanks for watching this Agilent ESOF EDA demo. Please also view the ADS Filter Design Guide demonstration.